Hello. Question 2 of the extended questions says, the opposite graph shows the variation of potential difference and electric current through a battery. Okay, through a battery. Find the electromotive force and the internal resistance of the battery. Okay, as you notice here, the variation of potential difference and current, they are inversely proportional because it is inside a battery. If we want the value of the electromotive force, okay, is going to be the highest point of the potential difference, and it is actually the point of intercept, or the point where the line crosses the potential difference axis. This is the axis of the potential difference here. Okay, let me draw it in red. This is the axis of the potential difference. Okay, and the line is this. So the point of intercept is the one circled in blue. This is the electromotive force. So here there's no need for calculation. I just say that electromotive force is the point of intercept with potential difference axis. It doesn't matter if it is on the y or on the x. Wherever it is going to give me the same information and the same answer. So E equals, we can read, it is 0.9. Okay, we pay attention. What unit is used in here? It is volt. So volt. If between the brackets, please pay attention. If between the brackets here, if it is a millivolt or microvolt or kilovolt or etc., etc. So we need to change when we write the answer. Okay. Now they want the internal resistance of the battery. The internal resistance, basically it equals to, okay, the internal resistance is going to be negative the gradient. Negative the gradient. Basically it is the gradient because we know that gradient is the y's over the x's, and we see that the y's here are the potential difference and the x's are the current, right? So let's find the gradient. Let me change the color. I'm going to use, okay, this one. So the gradient, we write the formula y2 minus y1 over x2 minus x1. Okay, we choose any 2 points from the graph. I'm going to choose this one and this one. Okay, so here this one will be y2, right? And here y1, right? Here is going to be x2, and here is going to be x1. Okay, because this is the first point and this is the second point. Okay, so y2 is 0.6, y1 is 0.3, x2 is 0.5, x1 is 1. So it's going to be 0.3 over negative 0.5. I guess the answer will be almost negative, yes, negative 0.6. Negative 0.6. This is what? This is the gradient. So I'll take the internal resistance. The internal resistance, I write it again, it's negative the gradient, which is negative minus 0.6. So negative negative is going to be positive, so internal resistance equals to 0.6 ohm. Okay? So always remember these two notes. Let me, I'm gonna use like a new color that I didn't use. Well, I'll go with the black. These two nodes that we depended on, if they give you the variation of potential difference and electric current inside the battery, okay, the line will be going down. They are inversely proportional. So if you want the electromotive force, always remember these words here. The electromotive force is the point of intercept with the potential difference or with the voltage axis, either on the X or on the Y. Always. This is, again, if the variation drawn is in a battery. Okay? This is note 1. Please remember. Okay? Note 1. Note 2 is when they ask about the internal resistance is going to be the negative of the gradient. Okay, it's going to be negative G. It's always. Okay, again, this always, I insist on it, and I repeat, if the variation is inside the battery, not in a resistor, no, in a battery. Okay, so this is note 2. Okay, I hope everything is clear. Feel free to watch the video again and write these notes in your notebook. And if you have any question or anything, please leave it under the video. Okay, have a nice day. Bye bye.